This lesson is an exploration in real numbers. um, the topics we're trying to cover are listed here. Adding, subtracting, multiplying, understanding the real number line, sets and intervals. You'll see as we go through. So natural numbers are basically our counting numbers, and that doesn't include zero. It's positive integers, not including zero. It actually took us a long time to come up with the idea of zero. We came up with negative numbers, most cultures, long before they came up with zero. Integers consist of all positive, negative numbers and zero, all positive, negative, and zero whole numbers. So those are called natural numbers, and you move that set out, you get a bigger, a larger set of numbers called the integers. And if you go even larger, we get to all rational numbers. A rational number is actually any number that can be written as a ratio. That's why it's called rational. And a rational is one whole number to another whole number, one integer to another integer. The numerator, or the second integer, cannot be zero, because if we get that, you get a divide by zero issue, which is discussed as being undefined. Because if you're dividing by zero, you're saying how many times can I repeatedly add zero till I get to the numerator? And you can do that either no times, it doesn't make any sense, or as many times as you want. In some instances, division by zero, the limit as you go to that process goes to infinity, because you could infinitely add zero over and over again, and you'd never get to the number on the top, which is in the numerator. But all these other numbers are examples of rational numbers. Now, there are other numbers that can't be expressed as the ratio of two integers called irrational numbers. Here are some examples of irrational numbers, and they, along with the other things we talked about, make up what we call the real numbers. So whole numbers, integers, rational numbers, and irrational numbers together, all these things make up the real numbers. The symbol for real numbers is this R-looking symbol with double lines. And when we talk about numbers, basically in mathematics and in this book, we're usually referring to a set of real numbers. Here is a Venn diagram, a really nice way to kind of visually understand the sets of numbers we talked about. Everything in the big rectangle makes up the real numbers. And you can see rational and irrational are on two sides, rational on the top, irrational on the bottom. Inside the rational is integers, and inside the integers are the natural numbers. Every real number has a decimal representation. And if it's rational, the decimal is repeating. So 1/2 is 0.50, and then the 0 repeats forever. 2/3 is 0.666, so the 6 repeats forever. You can see in these examples. So all of them can be expressed as a decimal with a line over the top because it repeats. Now, an irrational number is non-repeating. It goes forever and it never repeats. Okay. So you can see the examples below, square root of 2 and pi. Those are two examples of irrational numbers. Okay. Sometimes when we're working with irrational numbers, or even sometimes we work with rational numbers, you don't give the exact answer. Sometimes people use 2/3, they use 0.66. That's called an approximation. And if you're doing an approximation, you should use the approximation sign, which means approximately equal to. Okay. Move into some properties. The next step is to look at adding numbers. This property we're looking at, a plus b equals b plus c, is called the commutative property because the numbers can commute, which means to change position, and it still stays equal. Addition and multiplication are both commutative, so this is the commutative property of addition. They switch locations. Here's a list of properties. These properties are in our notes, so I encourage you to kind of look through them. Commutative, associative, and distributive. You can see all of the properties are written both with addition and with multiplication, or the combination of both at the bottom. Using the distributive property, you can see that in this case you're distributing the 2 to the x and the 3, and multiplication is implied when you don't have a symbol in there. So 2 times x plus 2 times 3 is after you distribute the 2, which gives you 2x plus 6 when you simplify it. Here again, we have the distributive property happening twice, distributing the a plus b to the x and the y, and then you're distributing the x to the a plus b and then the y to the a plus b. And the reason this last one's called the associative property is because at first we're associating the ax and the bx together separately. You don't have to associate them together because you can do addition in any order you want to. Next, on to addition and subtraction. So there's something called the identity. It's good to know what the additive identity is and the multiplicative identity. And the additive identity is 0. And you can always add 0 to a number and it doesn't change it. You can always multiply a number by 1 and it doesn't change it. 1 is the multiplicative identity. And we use those ideas frequently. Although it seems very simple, it becomes very important in mathematics for a number of reasons. Okay. So numbers have negatives. Sometimes they're called the opposites. So 5 and negative 5 are opposites. Okay, so 5 and the opposite of 5. Subtraction, it says, undoes addition. And I like how they wrote this here. Instead of writing a minus b, we changed it to a plus negative b. That's a very wise thing to do. Because addition is commutative. So if it's a plus negative b, you can do that in any order. You can do negative b plus a or a plus negative b. When it's a minus b, you have to do it in that order because subtraction is not commutative. Here are some properties of negative numbers. And you should probably glance through those when you have a chance. You can pause the video if you want and look at them. A minus b and b minus a are negatives of each other. Like 5 minus 3 is 2, and 3 minus 5 is negative 2. They become to be negatives of each other. And you can use that. There's a way in which you can use that, and you'll see examples of that oftentimes. So this is just working through properties of negatives, distributing the negative sign in A, same idea in B, distributing the negative sign, and then the opposite, or the negative of 7 becomes of Z becomes positive Z. We're also going to be looking at multiplication and division. As I mentioned, the multiplicative identity is 1, okay? And in addition and subtraction, 5 plus negative 5, those were opposites. They canceled out and gave you the additive identity. In multiplication, we also need something that cancels out, okay, which is called the inverse. So a times 1 over a gives you 1. That's called in the inverse. It's a's inverse, 1 over a. And that idea becomes fairly important too as you work through later mathematics. Division is the undoing of multiplication. And that's kind of how it's defined here in this book. So we write a times 1 over b as simply a divided by b. That's called a quotient or a fraction. A is called the numerator, b is the denominator. The denominator also is sometimes called the divisor. Okay? And a is sometimes called the dividend. So a little vocabulary for you. Again, more properties of fractions here. Multiplying, dividing, adding them together when they're common denominators and not cross multiplying. Feel free to pause the video and look at that if you want. It's also in our notes. Okay. And then some examples of working through these fractions. These are good skills that kind of make sure you are ready to handle an advanced algebra pre-calculus course. You have to have skills of working with fractions and understanding multiplication and addition. Okay. Good to have a good feel for what the number line is and where numbers fall on the number line. It's called the real line. So any real number we can place on this line somewhere. And you can see examples on this line of rational numbers, which are decimals that are that are repeating or terminating. Sometimes we call them terminating if they're non-repeating and terminating. And fractions or ratios, and irrational numbers. Pi is on there, the square root of -2 is on there, or the negative square root of 2 is on there. And you can see where the numbers fall. As numbers get more positive or larger in the positive direction, they're on the right, and larger in the negative direction on the left. Okay. We will order them from less than to greater than. So -5 is actually considered less than -2. on the number line sense. If you're talking about magnitude, that's a different conversation. But if you think about money, you'd rather have -$2 than -$5, because -$2 would be a not as much of a debt. So you'd actually have more money with -2 than 5. So that's how you use those symbols. Okay. So these are just placing points on the number line in order. Sets and intervals. This could be new to some of you, particularly some of the notation. A set is a collection of objects, and those things are called elements. So in this case, this says A is an element of S. So the object A is inside of the set S. And this one means B is not an element of S, so B is not in the set of S. For example, if Z is integers, then -3 is an element of the integers, but pi is not an element of the integers because pi is not an integer, it's an irrational number. Okay. So real numbers is the R, integers is the Z symbol typically. Usually the Z has double lines on it. You can also represent sets as a list. So this is set of A. So it's just the natural numbers from 1 to 6, inclusive. Okay. So this is called set building notation. It's good to understand mathematical notation, especially for those who are going on to higher level math someday. So in this case, what it's saying, I'll read it to you. It says A equals X such that, so that up and down line means such that X is an integer and 0 is less than X is less than 7, meaning that X is between 0 and 7, non-inclusive of 0 or 7. So then your job may be to understand what that is, right? That means I'm talking about integers from 1 to 6, okay? Because I'm not including 0 and 7. Okay. If S and T are sets, their union, this is considered the union. It's any elements that are in either set, okay, or both. Okay, so in S or T or both, you can anything. You just put them all together in one big pile. Okay, an intersection means they have to be in both S and T for them to count. Okay, there'll be a good example of this here. Sometimes when you do a union of two sets, you get an empty set. If I have the set 1, 2, 3, and T is the set 8, 9, 10, and I say what's S intersection T, there's nothing. There's no intersection between 1, 2, 3, and 8, 9, 10. So that's called the empty set. As a couple examples, here you go. So if S is 1 through 5, and T is 4 through 7, and V is 6 through 8, all of these being just integers, we're going to find unions and intersections of these things. So the union of S and T is all the numbers are in either S or T. So 1, 2, 3 is in S, 4 and 5 are in both, and 6 and 7 is in T. You get them all. The intersection of S and T is just 4 and 5. The only numbers are in both. So that's the intersection. The intersection of S and V now, okay, S was 1 through 5 and V is 6 through 8. There's nothing. They don't have anything in common. Those intersections don't have anything in common. Okay. So certain sets can be called intervals. And we'll talk about an open interval and a closed interval. If the endpoints do not exist in the set, we use the open interval if they're between B and A. If the endpoints are included in the set, use the closed interval. So that square bracket versus the parentheses is open versus closed. So using set builder notation, you can see that if we're talking about the interval from A to B non-inclusive, we'd say that's equal to a set of numbers X such that A is less than X is less than B, non-inclusive of A and B. Now if we use the closed interval, which is the square brackets, then X is it's equal to X such that A is less than or equal to X and less than or equal to B. You include the endpoints. Okay. And you can see a picture of that. Here's A and B not including the endpoints, the next one's A and B including the endpoints. Okay. And there's some more examples of this, whether you have open or closed intervals, so the parenthesis versus the closed bracket. And if you go to infinity or not. Now note that infinity is always used in open bracket. It's never inclusive because there's no specific number that includes infinity. Okay. So you can find unions, intersections of these. Here are some examples of doing that. You can feel free to work through those as you like. There's examples in the notes. There's examples in your book through your homework that show you those sets, unions, and intersections. Now I get to absolute value. I'm getting to the end here. Absolute value is really a measure of distance. That's really what we're looking for. And we see the absolute value of -3 is saying the distance from -3 to 0. The absolute value of 5, the distance from 5 to 0. How far would you walk? And distance is always measured positively. It's a magnitude or how far it is. So there's no, it's not directional. It's not like displacement if you take physics. It's always measured positively. The absolute value of a number, it becomes the positive of that number. Okay. And you can evaluate those. You know, the absolute value of 3 is 3. The absolute value of the opposite or -3 is also 3. Absolute value of 0 is 0. These are all distance measurements. Okay. Absolute value and distance. Here are some rules. And again, I encourage you to look through these rules to kind of get an idea for what they mean. Note that if you take the absolute value of A times B, that's the same as the absolute value of A times the absolute value of B. They can be separated, or if your two absolute values being multiplied, you can combine them into one larger absolute value. That's fine as well for multiplication and division. Okay. We use absolute value, again, to find the distance between numbers. So this notation here, we're going to use to represent the distance from A to B, and it's represented as the absolute value of B minus A. We will also see it's the same as the absolute value of A minus B. It comes out to be the same thing. The absolute value of the difference between the numbers gives you the distance between those two numbers. Okay. As you can see here, we're looking at how far away is -8 and 2 in the number line. And again, I encourage you to visually see that. Sometimes you might even want to draw that, put a number line on your page and get a feel for how far away that is at first when you're learning this. It's a good way to get a feel for what it's measuring. So you take 2 minus -8, it becomes it becomes 2 plus 8, which is 10. Or you could take the opposite of 2 and the opposite of 8, and you get -10 in here. I don't like how they've done it this way. I would again just do 2 minus -8 inside the parentheses, which becomes 2 plus 8, and you get 10. Okay. All right, that's it for our first introduction into this book, and welcome to the class.